Hello, and welcome to the AWS Lambda Networking Best Practices session. My name is Uri Segev, and I'm a serverless specialist solution architect. I've been with AWS for 3.5 years and spending the last 2 years focusing on serverless technologies. Today we will talk about Lambda networking. We will start by getting familiar with networking in AWS, and more specifically the VPC. We will then see how Lambda uses the network, and then we will finish with a list of best practices for networking with Lambda. So as promised, let's start with getting familiar with the VPC. So what is a VPC? VPC stands for Virtual Private Cloud, and it is your own virtual network inside AWS. You control its IP range, you define subnets, you define route tables, security groups, gateways, etc. Don't worry, we'll talk about all these terms in the next few slides. Why do you need a VPC? There are several reasons, and I'll discuss a few of them. The first one is that you want to build infrastructure using traditional compute services such as EC2, Elastic Compute Cloud, such as RDS, relational database services. All those require a VPC. Another reason might be that you are familiar with traditional network controls, and they're similar to the ones that you can get in a VPC. Maybe you have some strict network security requirements that apply to your business and/or its applications, so that's also a reason for using the VPC, and there are other reasons as well. So VPCs are your private network, your four walls inside AWS. It is defined by its IP range, or something called the CIDR block, which is pronounced CIDR block, and it stands for Classless Internet Domain Routing. The CIDR block controls the size of the VPC, meaning how many IP addresses you can have inside your VPC. As you can see in the diagrams here, I have two VPCs here. One of them is 10.1.0.0/16. That's a CIDR block of that VPC. That means that all the IP addresses in that VPC are going to begin with 10.1, and it gives me 65K IP addresses for that VPC. The second VPC is 172.16.0.0/24. That means that I only have 256 addresses in that VPC, in the second VPC. As you can see, the VPCs are spanning the entire region, meaning that they are spanning all the availability zones inside the region. You can have multiple VPCs, of course, in a region, and they can have overlapping IP, but it's really highly not recommended to do so. Otherwise, you will not be able to connect them in the future if you will need to. Once you have a VPC, you need to create also subnets. A subnet is, as its name implies, is a subset, a portion of your network. A subnet also is defined by its IP range. It's a CIDR block, which is taken from the parent VPC, from the IP range of the VPC itself. A subnet is bound to a specific availability zone. So your VPC will usually include multiple subnets in different availability zones. Subnets are also very useful for compartmentalization. For example, in a traditional 3-tier web application, you will have subnets for the web tier, you will have different subnets for the application tier, and then you will have a different subnets for the database tier. Each one of the applications, the servers, the databases will run in their own subnets, of course, in multiple availability zones. As we mentioned, a VPC is your four virtual walls of your network inside AWS, but without having any windows or doors, no traffic will be able to enter or leave your VPC. And for that exactly, we have gateways. A gateway controls inbound traffic into the VPC and outbound traffic out of the VPC. And we're going to discuss a few components here. The first one is the Internet Gateway, or IGW. The Internet Gateway allows incoming traffic into the VPC and outgoing traffic from the VPC to the Internet, all that from public subnets. And we'll discuss what the public subnet and private subnet means in a future slide. And that gateway only allows for outgoing traffic to the Internet from private subnets. Now, when I'm saying only allows for outgoing traffic, it is important to understand that it allows for traffic to be initiated from the VPC to the Internet. Also, of course, it allows also the traffic to come back on those connections. It does not allow for traffic to be initiated from the Internet into the VPC. The third gateway is the transit gateway. The transit gateway is used when you need to connect VPCs to other private networks. Those other private networks might be other VPCs, It can be your on-prem data center using Direct Connect or not VPN. And when you need to do that, you can do it using a transit gateway. If you only need to connect 2 or 3 VPCs, you can also use VPC peering, which is not mentioned here on the slide. And the fourth one is when you need to access AWS services in the region. In this example, I'm showing Kinesis data stream. For those cases, you use something called the VPC endpoint. A VPC endpoint allows us to access AWS services that support VPC private link directly without needing to go through the internet gateway and the NAT gateway. The next term is a route table. Route tables control how the traffic flows from the VPC outside. There is a route table per VPC, and then you can also override that in different subnets. They can have their own route tables. As you can see here on the list, the route table is a list of rules that indicates that what you want to send, what the target is. When the destination is such and such, you need to use that target, the one on the right, to go to that, to reach to that target. So, for instance, all the route tables have a local route, which indicates that all the IPs belonging to the VPC are local, so there is nothing special to do there. But also, if you see in the first one at the top, for the public subnet, you see that 0000/0, which means all IP addresses which are not mentioned above that, which means all the internet addresses, they should go through the internet gateway. In the private subnet, you see that there is also a route for 0000/0, but that will not go through the internet gateway. It will go through the NAT gateway. Again, we said NAT gateway is used for outgoing traffic from private subnets. We also have an entry in the second route table for the Kinesis data stream, again as an example, that will go through a VPC endpoint. So if a resource in the private subnet tries to create a connection to Kinesis, we will check on the route table how to route the request, and we see that the IP address of Kinesis needs to go through the VPC endpoint. We will route the request through the endpoint. So I mentioned public and private subnets. It's important to understand there isn't such thing. You cannot go into the console and define a subnet as being private or public. All the subnets are private unless they have a route to the internet gateway. If they have a route to the internet gateway, it means that resources in that subnet have access to the internet. Otherwise, they do not have access, and the subnet is a private subnet. It is not enough to have a route to the internet gateway. You also must have public IP addresses assigned to those resources inside your VPC, inside that subnet. In order to be able to communicate with the internet, you must have a public IP address. And it's not the IP address of the VPC. The VPC, even though it may be in a range of public IPs, those are not accessible from the internet or to the internet. You must allocate a public IP address from the range of AWS in order to be able to communicate with the internet. So a public subnet is a subnet that has a route to the internet gateway, and it has resources with public IP addresses, which can be allocated by default or can be explicitly allocated if needed. The next concept is a VPC security group. And so VPC security groups are virtual firewalls for your instances. They control inbound traffic to the instance and control outbound traffic from the instance. So you can control which instance can talk to where or from where they can accept traffic. They also can be used as sources or destination for traffic. So I can say VPC from one security group can get connections only from another instance which has a specific security group attached to it. They are stateful, which means that if I have a rule that allows for traffic to go outside on a specific port, I do not need to create a special rule for the return traffic. It's automatically managed and allowed. That's in contrast with the network ACLs, the NACLs, which are stateless virtual firewalls for your subnet, which do not have, they are stateless, so you need to create the rules for both outgoing and also for the return traffic. The last concept I want to talk about is a network interface, elastic network interface. It is a virtual ENI, usually attached to instances, but not always, as we'll see in the next slides. When we create an ENI, we always get a private IP address from the CIDR block of the VP of the subnet it is allocated from. It can have more IP addresses and the security group, of course, that controls what traffic can come in or out of that specific ENI. So now that we have seen all the concept, let's put it all together. We have a region. In the region, we have multiple availability zones. We have also different AWS services. We can see here Kinesis data stream as an example. We create a VPC. The VPC spans all the availability zones in the region. We create subnets and we attach route tables to those subnets. We create public subnets, private subnets, and with the appropriate route tables. We then create and attach the different gateways: internet gateway for incoming and outgoing traffic for the internet for public subnets, NAT gateway to allow outgoing traffic from private subnets, AWS transit gateway for controlling traffic to other private networks, and VPC endpoints to allow traffic to AWS services, to different AWS services that support private link. And then we, of course, create different resources, instances, or other compute that has their security groups that control the traffic, and they can talk among themselves based on the security groups, of course, and they can talk to the internet or to other services based on what they need. VPC is a complex service. I do recommend that you look at those resources to get some more information about VPC. So now that we are all experts on VPC, let's see how Lambda functions utilizes the VPC for networking. And we will start with the one slide overview of what Lambda functions are. Lambda functions are serverless compute, where you give us some code, some business logic, some function. It's called the Lambda function. You give us a function, and we will invoke the function when a specific condition will happen, when a specific trigger will occur. And those can be one of many things. For instance, it can be an API call to API gateway. It will trigger a Lambda function. It can be a message into an SQS queue. It will trigger a Lambda function. And there are a lot of such sources that will trigger Lambda function. The Lambda function itself has a handler. A handler is where you put your business logic. It receives one object, which is the event object, which tells it why it was invoked, what is the name of the object on S3, what is the message that was received from API gateway, and so on. And that is where you put your business logic. Your business logic, in most cases, will need to contact some other services, some other microservices, some databases, some other AWS services, or some other public API. To do that, it will need to use the network. It needs to access those services over the network. And that's exactly why we are here, to understand how AWS Lambda uses the network to access all the services that it needs to do. So, as Lambda functions are serverless, it means that you do not need provision any compute resources. We take care of that for you. The Lambda service takes care of that for you. And all those Lambda functions runs on compute resources inside the Lambda service VPC. All the Lambda functions run in a Lambda service VPC. They run on micro VMs. They have access to the network. They utilize the network to do all the things that we talked about before. And there's also a specific path that's used by Lambda to send the log messages to CloudWatch logs. That's a different path from the one used by the application itself, by your code, by your business logic, when it needs to access the other services. Now, when you give your function more memory, it gets more CPU, and up to a point, it also gets some more access to bandwidth, to network bandwidth traffic, to network bandwidth. All the invocations of Lambda functions are done through the service API. You cannot invoke the Lambda function directly by calling the Lambda handler, the handler function. You need to do it only using the function, using the service API. Regardless if you're invoking it directly using the service API, or if you're using it through some other trigger like API gateway. API gateway also will invoke the function using the public service API. The service API is available to the public internet, so you need to have access to the public internet in order to invoke the Lambda function, or the Lambda service that invokes it needs to have access. If you're running inside a VPC, now we have also support for VPC endpoints to invoke, to access those, the service API. The Lambda function has no inbound traffic. You can establish connections from the Lambda functions, but you cannot receive connections. You cannot do a listen on a port in Lambda function. So when you create a Lambda function by default, it has access to the entire internet, right? It has access to the internet, it has access to any public API, it has access to all the AWS services, assuming you have the right permissions to, of course. So you can create objects on S3, you can change the read data from DynamoDB and so on. But you do not have any access to private resources inside your VPC. Now, what happens when you do need to have access to the VPC? For instance, what happens if you need to access a database in the VPC? If you need to read something from an Elastic Cache cluster, what do you do in that case? In that case, you attach the function to the VPC. You attach the function to the VPC. You do not run the function in the customer VPC. The function still runs in the Lambda service VPC, but we are attaching it to the customer VPC. And let's see how we do that. The first thing that we do is we allocate an ENI for each one of the subnets that we configure the Lambda function to be invoked in. We allocate an ENI. The ENI will receive a private IP address from the IP range of those subnets. Each one of these ENIs will get one IP address from the subnet. We will attach the security group to that ENI. And from that point, all the traffic that goes from the Lambda function, all your own traffic, the one that you use to access some database, for instance, will go through the following path. It will go from the Lambda function to a service which is called, a device which is called VPC to VPC NAT, or for short V2N. This is all true, but not excluding the logging, which is sent still the same way, as you can see in the diagram in the bottom. From the V2N, the traffic will go through the ENI, and then it will go, it's inside the VPC, and it can access the different resources in the VPC, of course, allowing the security groups allows it. Invocation of the Lambda function still happens through the service API. If you have resources inside the VPC that need to access this Lambda function, they still need to have access to the internet or using a VPC endpoint to invoke that Lambda function. It doesn't change the fact that the functions themselves are triggered using the public service API. A few words about V2N. The ENIs are created during the function creation time or update time, and not as it was before we had V2N, where the ENIs were allocated during the function invocation. That caused a very long cold start time, up to 15 seconds it could have been or more. Now with this, when we create the ENIs at function creation time, then invocations, when they happen, do not incur that long cold start. It can happen less than a second. With V2N requires, of course, that the function has the right permissions to create those ENIs, delete them, and so on. ENIs are shared by all the functions that are attached to the same subnet and utilize the same security group. So if you have two functions attached to the same subnet and both of them are using the same security group, we're only going to create one ENI in that subnet. Saying that, if we have a lot of traffic going through that subnet, then we're going to automatically auto-scale the number of ENIs so that they will support the needed amount of traffic. V2N is based on the hyperplane network technology. It's a completely managed service. You don't need to do anything special. Once you attach a function to a VPC, automatically we will create the ENI, use the V2N, and so on. You don't need to do anything special, and there is no additional cost for you to use this feature. A few things to note about V2N. First of all, it's all the security groups that you attach to the ENI, network ACLs, route tables, everything still applies. So all the traffic that is originated from the Lambda function is going to be routed across to according to all the rules that are relevant for instances running inside the same VPC and the same subnet. V2N is still a NAT. It's still a network address translator. So that means that also that you cannot have incoming traffic. Only you can initiate traffic from the Lambda function, but you cannot have incoming traffic to the Lambda function. Again, of course, you can have the return traffic, not new initiated traffic. V2N interfaces, the ENIs that are allocated, do not have public IP addresses. If they do not have a public IP address, you cannot also attach an IP address to that. It means that they cannot talk to the internet. They cannot have any access to any public APIs on the internet. Now you have access to private resources. What happens if you do need to have access to public resources as well from your function? If you do need to do that, then you must attach your functions to a private subnet and utilize NAT gateway in order to be able to get out of the VPC and access the internet just as any other resource that is running inside the VPC. So again, if you need to access the resources in the VPC and outside the VPC, you will need to use a NAT gateway, and you must allocate attach the functions to a private subnet. Another option is if you need to access AWS services, you can use the VPC endpoint so that you do not need to go through the internet. So if you're using the NAT gateway, as you can see, the traffic goes from the function to the V2N, through V2N, to the ENI, through the NAT gateway, to the internet gateway, and then to the internet. If you go to an AWS service using the VPC endpoint, it goes from the Lambda function to the V2N, to the ENI, to the VPC endpoint, and then to the service. A few words about Lambda and API Gateway. API Gateway supports private APIs, which means that only resources running inside the VPC can access the APIs. And regardless of what the backend integration of those APIs are, right? They can access public resources or private resources. API Gateway also supports something called VPC Link that allows the API to access resources inside your VPC. Again, regardless if it is a public API or private API. All APIs, regardless if it is a private API or a public API, you do not need to use a VPC link to use a Lambda function. It doesn't matter if the Lambda function is attached to VPC or not. Okay, so we discussed what is networking in AWS. We discussed how Lambda networks works when we have default functions as well as when we have VPC attached functions. Let's go over some best practices. So let's start by deciding if we need to attach a function to a VPC. And there are a few reasons why to do that. If your function needs to access a resource inside the VPC, go ahead and attach the function to the VPC. If you need to access a database, Elasticache, Elasticsearch, whatever, a microservice that you developed, and it's a private service, attach the function to the VPC. If your function needs to access a resource in another private subnet, another private network, on premises, another VPC, and so on, also you need to attach the function to a VPC and connect that VPC to the other network using VPC peering, transit gateway, direct connect, whatever the means are, but you need to have it inside the VPC. The third reason would be if you have strict exfiltration requirements for your traffic. You want to be able to control where the traffic can go. You want to be able to maybe do some deep packet inspection using some appliance. You cannot do that if it is a default function. You will need to deploy the function, to attach the function to a VPC, and then use the route tables to control where the traffic goes or security groups and so on. And the last reason is that if all the traffic that originates from your Lambda function must come from a pre-configured IP address. For instance, you need to penetrate through a firewall and you need to configure the allow list in that firewall, then you need to know where the traffic is coming from. You need to know the IP address. If you use a default Lambda function, you will not know where it's coming from. To do that, you will need to attach the Lambda function to a VPC, use a NAT gateway, and use something called an elastic IP address, which you can allocate and attach to the NAT gateway so that all the traffic that goes from that specific NAT gateway will come from a specific known IP address that you can control when you release it and you can move it to a different appliance and so on. In all those cases, please go ahead, attach your function to the VPC. In the other cases, leave your function as a default function accessing the public internet. Lambda, as any other serverless service, utilizes multiple availability zones. It's highly available. It runs on multiple availability zones. For that reason, you should, when you attach a function to a VPC, you should also attach it to multiple subnets in multiple availability zones. If you do not do that, you may lose your availability. If one availability zone goes down, and that's the availability zone that you use to attach the Lambda function to, then you're going to lose the access to your VPC. So you must use multiple VPCs, multiple subnets in multiple security groups, and attach your function to all of those, so that you don't lose that. You still maintain the higher availability. You're more fault tolerant, and your traffic is actually going to be routed across multiple ENIs, which will reduce the need to autoscale it in the future, maybe. Utilize VPC endpoints. VPC endpoints, as we said, are used when you need to access any other VPC, AWS services that support private link, but also any other service that partners or yourself develop that use private link technology. So when possible, use the endpoints instead of the NAT gateway. And there are two main reasons for that. You can see some more here, but it avoids going through the public internet, as well as it reduces the price dramatically compared to the NAT gateway. VPC endpoints are cheaper than NAT gateways. When you need to access other VPCs, we already talked about it to some extent. Use VPC peering, use a VPC transit gateway to connect the two. If you use VPC peering, you can do it inside the same region, across regions, with other AWS accounts. If you do that, the traffic remains on the backbone. It is encrypted when it goes across regions. So it's really recommended when you need to access other networks. Right size your VPC, right? If you don't have enough IP, if you choose smaller VPCs with smaller subnets, you will not be able to autoscale. You will not be able to deploy enough resources. So make sure that you have large enough VPCs and subnets. There is no reason not to use large ones. There is no extra cost for the size of the VPC. So use a /16 for the VPC, use an /20 or 24, depending on the number of subnets that you need for the subnet. So you will give you enough room for growing. You can restrict, you can control that users will only be able to create Lambda functions attached to VPC using IAM condition keys for VPC. That way you don't allow users to create Lambda functions which are public if you require that thing. And last thing is that you need to be aware of limitations. As with any other service, you must be aware of the limitations that the service imposes. For instance, Lambda functions allow only outbound traffic. We already discussed that. Port 25 cannot be is blocked for outbound traffic unless you are attached to a VPC. Only TCP and UDP. You cannot do ICMP. You cannot do pings and stuff like that. And there is a limit of 250 hyperplane ENIs per VPC. And those ENIs are the ones that are used by Lambda, but they're also used by the network load balancer. They're used by NAT gateways, by private link, by Elastic File System. So be aware that this number can grow without you being aware of that. So if you need to ask for a limit increase for those ENIs. In summary, VPC is a complex service. I encourage you to go and learn that service. Follow the best practices that we went over this in this slide. Use VPC if you need to. Do not do it if you don't. And don't forget, we attach a Lambda function to the VPC. We do not run the function in the customer VPC. Thank you very much. I hope that it was very beneficial for you. And I do ask you that you please don't forget to complete the survey after this session. Thank you and goodbye.